Right, data science and industry. So industry, just another word for corporate job. So someone working at a company. Google is considered industry, IT is considered industry, those kinds of things. Now, the big tech companies, I'm going to, for the sake of time, I'm not really going to reference them. So like Facebook, Amazon, Google, although I'll give examples of their applications of data science. They're definitely outliers. They're definitely exceptions to the rule in what data science looks like in industry because they have so many people, some of the best people in the, in the tech industry and things like that. So first and foremost, in business, everything revolves around business value. Now that's kind of an abstract way of just saying for what you paid, what did you get back? And what that could potentially be is just simple money and profits. Sales have gone up. It could also be time. So did you put some effort into making a process automated, making it faster, so that way the next time people do these, it doesn't take the same amount of time? Did you make it more efficient? It could also mean new customers. So did you expand into a new demographic of audience that wasn't currently buying your product, but now they are? Did you improve a customer's experience? So like you're using, Amazon, they're constantly making feature updates, and those feature updates are focused on you. So that way you have a more positive experience when you're using Amazon, because your positive experience means more positive experiences, means you'll use it more, and etc. So like those kinds of things are considered business value, and everything revolves around that at its core. Not all companies are mature enough to explicitly say that how close are we? Are we doing this? Did we actually get one new customer? But everyone's marching generally to those goals. And I want to emphasize that because it's important to remember in industry, everything costs money. Your time, your effort, you simply being there working for them costs them some sort of dollar amount. And it's really important that you are able to show some returns for that. And what that then translates to is, well, what does data science look like in practice? Because if you're expected to do everything, computer science, domain knowledge, math and statistics, et cetera, et cetera, et cetera, you're probably going to not be as efficient as possible. So that's why the center of that Venn diagram to the right says unicorn and not data scientist, because typically that person doesn't really exist. The person who's incredibly amazing at computer science has the most in-depth subject matter knowledge of whatever industry you're in, and also has this intense math knowledge. You're not going to really find that person. And even if you do, that's not in your favor. What is in your favor is putting together a cross-functional team. So someone who's really good at programming, someone who really understands the company, what their purpose is, what the business is, how to capitalize on the customers, someone who's really good, maybe a PhD student who really understands the math. You put all of them on one team, you make them work together. Now, what that naturally means is you have different roles come in. You have people who can manage that team. So a manager who's really good with people, who understands interpersonal communication, who can work through their social problems, who can get them talking together. That's a data science related role. But you really won't get a company who's they may say it, but you really won't get a company who's trying to hire that unicorn, because even though that's a fantastic idea, that's not really what happens in practice. You want to bring people together and let them shine in their respective areas. All right, so next slide. So I know we're running out. So 3 big topics I want to focus on in industry. There's kind of a lot, but 3 big ones. Efficiency. Like I mentioned before, your time is money. So writing code efficiently matters a lot. If you're taking an hour just waiting for some model to run, that's not necessarily the most efficient. A software development lifecycle, pretty much you have a practice region, you have a live region. You're constantly trying to make your data science work in live function. So you can practice all you want, but think about like a scrimmage versus the actual in-game. You can scrimmage all you want, but the whole reason you scrimmage is so your in-game is as great as possible. And the 3 R's is repeatability, reproducibility, and replicability. In an industry, it really, really matters that you are constantly thinking in those contexts. And then one final slide, just outlining the 3 typical roles you'll see in industry, the average salary for the nation. So that isn't geographically adjusted. So New York may be higher, Midwest may be a little bit different, and then SF may be different as well. But typically data analysts are more generalized. So you'll find data analysts who can write a variety of functions. They create reports or dashboards for management, for finance to whatever. Data scientists work a little bit more advanced skills. Machine learning and AI engineers, they're more software development heavy. So they put these data science models into production. So into that live, help make data science works in the game. And then also these are the skills. But ultimately, things are still being figured out. People are still trying to conceptualize and find their way in their space. That was really it. I think this was mainly to have a slide for if people had questions, how to break into this field. If you go one slide back, try to capitalize on these skills as much as possible. Learn Python, learn it really well. SQL is really, really important because companies have their data in databases or in the cloud or in data lakes, essentially some storage unit. You need to write SQL to get it out of that. And data visualization, I think we talked about that. The math stuff, it really, really varies, but don't, again, what was said before, don't let the math scare you. There's a lot of really, really cool applications, and we need you in this field. And it would be a shame if just some math was the reason that potentially scared you away.
Mm-hmm. So thank you, Ani. Certainly appreciate it, and appreciate everybody with the Midas staff that gave us a very engaging and very thoughtful discussion. We will actually be setting up some evening optional Slack chat. So if either one of you want to participate, for an hour or so interacting with our students and answering questions, we'll be doing those starting next week, and I'll certainly reach out to you to do so.